Magic is creating the illusion that you can defy the laws of nature.
Magic is creating the illusion that you can defy the laws of nature.
Science is the study of how the natural world works. This is science. Hi, I'm working on a new show. It's a show about problem solving. This is the poster for it. The show is called The 7 Steps of the Engineering Process. Pretty cool, right? I'm going to Huntsville, the Rocket City, this weekend to try it out. I'm super excited about the show, but I have to leave my pet at home. Honestly, I'm a bit worried about how to feed him. If I put out enough food for the whole trip, he won't save any. He'll eat it all right away, get sick, and have no food until I get back. My pet, he is as dumb as a stick. In fact, he is a stick. This is Fetch. Fetch. That's his name. I know that's his name because I saw a woman at the park yell, "Fetch!" and throw him. A very kind dog ran after the stick to save him and brought him over to me. Fetch and I have been friends ever since. I've got to find some way to feed Fetch while I'm out of town. I'm not even sure how to start solving the problem of feeding Fetch. Oh, my engineering design process sign fell. Something invisible is at work here. Of course, you and I know it's gravity, that invisible force that is always acting on objects. Hold on while I put this back up. I have to add an opposite force to the friction that's pulling down on the poster. This magnet ought to do the trick. That should hold it. Fetch. I don't even know how to start solving the problem of... Wait a second! The engineering design process. It's a way to solve problems. If you follow these steps, they suggest ways to think about a problem. I should use the engineering design process to figure out a way to feed Fetch. Ask, research, imagine, plan, create, test, improve. Ask, research, imagine, plan, create, test, improve. This is great! What do I need to do first? I think I'll start right here on step 5. Nah, I'm joking. I'll start here at the beginning on step 1. Ask to identify the need and constraints. That's a fancy way of saying, what problem do you need to solve? And are there any special rules we need the solution to follow? Yeah, I can answer those questions. My problem is this. I need a way to feed Fetch while I'm not here. I have 2 special rules. Special rule number 1, I'm leaving Friday afternoon for the Rocket City and coming home on Sunday afternoon. So I need a way to automatically feed Fetch once on Saturday afternoon, 24 hours after I leave. I'd also like it to work without using any electricity. Sometimes the power goes off at my house, and if that happens, any solution involving electricity won't work. I don't want Fetch to get too hungry. Sticks get very cranky when they're hungry. That's step 1. Feed Fetch in 24 hours, no electricity. Step 2, research the problem. I'm doing some computer research into automatic pet feeders, and I've discovered a couple of things. First, no one but me has a pet stick. That's weird. Sticks make great pets. The second thing I've discovered, all of these pet feeders for sale require electricity for the timer to release the food. I'll need to think up something that doesn't need electricity, takes 24 hours, and can release Fetch's food. What do I have that takes about 24 hours to complete? I have an idea. When I go camping, I fill my ice chest with ice, and the next day, it's mostly melted. Maybe I could use that ice melting as a kind of timer. But how? Imagine possible solutions. I could put the ice chest on one side of a teeter-totter and a bowl of food on the other. As long as each side has the same mass, it will balance. As the ice melts and the water runs out of the valve on the ice chest, there will be less mass in the ice chest. The forces will become unbalanced, and eventually the mass of food in the bowl will be greater than the mass of the ice chest, and the food will end up resting on the ground. Not too bad. Thanks, gravity. But that water from the ice chest would get everything super wet and nasty wet. Also, my ice chest is pretty big, so the teeter-totter would have to be really, really huge. Probably too huge to fit in my house. And Fetch might climb up the teeter-totter and get to the food too soon. That's a lot of problems. Let me see if I can think of another possible solution. I like the melting ice as a timer idea. Maybe there's a way to use it that doesn't get everything wet. I've got another idea. I think it's better. It won't splash water, and I don't think I'll need a teeter-totter. Let me show you what I'm thinking. I need to find the point where, when the block of ice is in the chest, it won't tip over. I'm going to put my ice chest on these pieces of PVC pipe. They should allow the chest to tip over when the ice melts. I'm setting the pipes under it in such a way as to make sure that it balances until the ice melts. The weight of the block of ice will hold the ice chest still until the ice melts. You see, adding mass to this side affects the motion of the object, or lack of motion in this case. Remember, from Newton's second law of motion, that changes in the motion of an object depend on the sum of the forces acting on the object, as well as the mass. So when the ice melts and changes to water, and the balance gets out of whack, the ice chest will roll over on the pipes to this side. Now, I have to figure out a way to use that motion to serve Fetch his food. I think this is gonna work. Let's go to the next step, right there. Plan and select a probable solution. I think the ice chest out of balance is a pretty good idea. Probably easier than the teeter-totter plan. So I'm gonna go with ice chest out of balance. I need some other parts to make this idea work. I've got the ice chest and a couple of pipes. I also need a scoop and some way to hold it up. I also need some way to get the food from the tipped over scoop into Fetch's bowl. I'll get all these things and we can move on to the next step. Create a prototype. I looked up the word prototype. It means first model. I'm building a prototype because I'm not quite ready to build the real thing. A prototype is a test model. So I'm going to start at the result end. I need the scoop up here to tip over and pour stick chow into Fetch's bowl. What is stick chow, you ask? Sprout Stick Food, the all-in-one food for sticks. Your stick will love it. This is Fetch's bowl. The scoop needs to be on the counter, so Fetch can't get to it before it's time to eat. I've attached this scoop to a 2x4 so that it will be easy to tip over, and it will pour into Fetch's bowl. I'll stand it up right here. Force has to act on the scoop to make it tip over. It won't just tip over by itself, you know. According to Newton's first law, an object at rest remains at rest until acted on by an outside force. An ice chest can apply the force. When the ice melts and the ice chest tilts over, it will hit the scoop and tip it over. Then the food will pour from the scoop into Fetch's bowl. Hold on a second. You may not think that building a prototype is important, but it's super important. Lots of problem solvers, using the engineering method, build prototypes of their solutions. Even world-famous illusion designers make prototypes first. Illusion designers create magic tricks that make people appear to float in the air, or appear to vanish magically, or even be cut into pieces. Even these problem solvers test the solution before they begin to build. This is why prototypes are helpful. I have a very, very famous illusion designer friend. His name is Jim Steinmeier. He's created illusions for Disney, big shows on Broadway, and even world-famous magician David Copperfield. Here's what he had to say about building prototypes.
Oh, every project starts with sketches and then turns into a little model. It's just a few pieces of cardboard or wood stuck together with tape, but that's your first chance to shake hands with your idea and see it in 3 dimensions. That's when old questions get answered and new questions get asked. Yes, it's just a cardboard model, but it's one of the most exciting parts of the process. Jim Steinmeier.
Cool, right? Even world-famous magic trick makers use the engineering process, and they make prototypes first. And you should too. Speaking of magic, let's take a quick break and watch some. Magic is creating the illusion that you can defy the laws of nature.
There was once a man named Henry Ford. He said this: whether you think you can or you think you can't, you're right. He meant your attitude plays a big part in your ability to solve problems. Our minds are only capable of seeing things that we believe are possible. If you don't think you can make the baseball team, your mind won't look for ways to make it possible because you think it's impossible. If your mind thinks it is possible, it might actually be. There is no assurance that you will make the baseball team, or become a cheerleader, or make the honor roll. All these things take hard work, but thinking it's possible gives you a better chance because your mind will find ways to make it possible. Think it's impossible? Your mind will find ways to make it impossible. Think you can't? You can't. Think you can? It just might be possible.
We're using the engineering process to feed fetch while I'm gone. So far we've covered ask, research, imagine, plan, and create. Now we're ready for the next step. Test and evaluate our prototype. The first thing I measured was the amount of ice that would melt in 24 hours and would balance the ice chest. When the ice melts, this will cause the ice chest to tip over. When the ice had melted, I poured that water into a measuring cup. I needed to know the amount of water required for the testing process, instead of waiting 24 hours each time I tested it. First test. Chest has melted ice in it. I'm holding it in place and I'll let it go for the attempt. As I evaluate test 1, I can see we need to move the ice chest and pipes closer to the scoop. I'll do that and we'll take another try. Ready for test 2? That's a problem. The scoop does not fall in the same place every time. Sometimes it will tip over and drop food in the wrong spot. I need a way to make the scoop fall the same direction every time and get all of the food into Fetch's bowl, not all over the floor. This time, my evaluation suggests I need a way to make the scoop fall the same way every time. Let's try this. Now it falls straight. We're set for the next step. Improve and redesign as needed. Let's do a final test to make sure it will work. The amazing Steve Trash stick feeding device is ready for action. My car is packed and I'm leaving for the magic show. The ice is loaded and I'll be back in 48 hours. If everything works, Fetch will be happy and well fed when I get back. Look at that. The feeder worked, and Fetch is happily sleeping. I'm gonna try not to wake him up. He can get very excited when I get home from a trip. Let's review the engineering process. Ask. Identify the needs and constraints. I needed to feed Fetch while I was gone. The constraints were he needed to be fed 24 hours after I left, and I really didn't want my solution to involve electricity. What is the problem you're trying to solve? And what are the rules that your solution must adhere to? Essentially, you must answer, what can I do and what can't I do to solve the problem? Research the problem. Find out if others already solved this problem. Most of the automated pet feeders I found were electric. My power goes out a lot, and this means that an electrical feeder might not work. And Fetch would go hungry. This would not be good. It is important to me that Fetch be fed. So using electricity was not a good solution. Do the research, look it up. Have others come up with solutions that would work? Maybe solutions that others came up with worked, but not for my situation. What if you could adapt their solutions, change them a little bit, or have others come up with solutions that were really elegant and worked well? Could you use those solutions? At this point, feel free to brainstorm wild solutions to the problems you face. Sometimes brainstorming is where really good ideas come from. I love to scribble my solution ideas out on yellow notepads. If you enjoy drawing, scribble your solutions out on a piece of paper or on your laptop. Many of our most creative solutions and greatest ideas come from deep in our minds. So present the problem to your mind, make sure your mind is aware of the parameters, and then let it go wild. You may be surprised at the solutions you can come up with. Have you ever been trying to remember a word or someone's name and you just couldn't, but much later, when you weren't even thinking about it, that person's name or the word just popped into your head? Yeah, your mind is always working, even when you don't realize it's working. Why not put it to work on your problem? Tell your mind to go to work on your problem, and you may be surprised at the solutions it can come up with. Plan a promising solution. So your mind has created a whole bunch of great ideas to solve your problem. That's fantastic. But now you have to choose only one. You may have lots of good ideas, but you should pick the best one, or the one that seems to have the most promise, and run with that one. Remember, this is the engineering process. And if the solution that you've chosen doesn't work, you can try another solution later. But for now, we'll create a prototype of the solution we believe will work. Here's where we get our first clue whether our solution will work or not. Prototypes can be very helpful when designing a solution. Remember, you can use cheap, simple, available materials to work out a prototype. Even world-famous illusion designers like Jim Steinmeier will use cardboard, tape, and sticks to see if their design will work. Eventually, the illusion they build will be made of strong, durable, state-of-the-art materials. But right now, you're just looking at the design possibilities. So you can literally make it out of whatever you have that can stand in for the final solution. Test and evaluate the prototype. This is the beauty of using a prototype. You can see what's working and what's not working about your design. With Fetch's feeder, the food went everywhere when the food wasn't being guided to the bowl. I didn't know this until I tested it. You can learn so much by testing. This part of the engineering design process is sometimes called trial and error. Look at what's not working and then improve. Look at your results. Improve and redesign as needed. Originally, Fetch's food went everywhere, so we needed to improve the design. I made some guides that would steer the food so the scoop arm would fall the right way. I learned from the test that our design needed improvement. I tested the prototype again and realized the food was still spilling everywhere. So, you made the prototype, and maybe you need to use more of something, or less of something, or maybe your design solution doesn't work at all. This is not a terrible thing. It's actually great. Now you know what won't work. You can design the process again, and you are now a little closer to a very good solution. If we look on the engineering design process, we see it's a circle. Ask, research, imagine, plan, create, test, improve. Sometimes, even with all the testing, your solution doesn't work in the way you expected. That's when you start over and go through the steps of the process again. Sometimes you might even have to go through all the steps many times before you solve a difficult problem. The good news is that the engineering design process gives you a great way to solve problems. Oh no! Good to see you too, Fetch. Oh boy, good boy, good boy. Good to see you too, Fetch. Good boy. Go, Fetch. Remember, the engineering design process gives you a great way to solve problems. Step 1, ask. Step 2, research. Step 3, imagine. Step 4, plan. Step 5, create. Step 6, test. Step 7, improve. If necessary, start the process over again. Work it until you solve the problem. Oh no. Good boy, Fetch.
And now, something silly.
about that was my fault. Cut. Oh, wow. Okay, that was it. Then never mind. We still rolling?
Yep.
Oh boy. Okay, then let's go. It's too many wets.
Also,
Sprout stick food. The all-in-one one more time. Look at that. I can't remember what I'm supposed to say. I'm gonna go back out now.
Biologically, chemically, atomically, everything is connected.
Major funding for this program provided by Jason Isbell and Amanda Shires, Keep Alabama Beautiful, and Northrop Grumman.
Yes, the ocean is deep, and the sky